What are the varieties of confocal microscopes?
Well, there are two main varieties to work with. Variety 1 is the spinning disc confocal. Variety 2 is the laser confocal microscope.
Nick mentions two variations of confocal microscopes. They are laser scanning and disc scanning, but there is one more that can be added to the list, and that is the multiphoton laser confocal microscope. The most commonly used type of confocal microscope is the laser scanning microscope. Using a laser and an illumination pinhole, it allows for a point-like light source illumination of the sample, which means that once you load your sample onto the stage of the microscope, the laser and the illumination pinhole will allow for the detection of the specific point of that sample that you are trying to view by illuminating the fluorophores contained in it. Therefore, we can really focus on that one cell which we are trying to study. It also uses a photomultiplier tube as a detection device. The detecting pinhole can be used to get rid of the background signal that we are most likely to see in our sample, because any contaminants in the sample can take up the fluorophores. And if that happens, you will not be able to view the specimen in question. Multiphoton laser microscope is another type of confocal microscope. It uses two lasers to view a single point in a specimen. Two high-energy lasers are focused on a single point in the sample. The two lasers themselves are of a longer wavelength, but when they intersect, they produce a shorter excitation. For example, two 700 nanometer infrared lasers will produce a 350 nanometer UV excitation. The excitation occurs when the two lasers meet, and therefore we get fluorescence. The third and another common type of confocal microscope is the disc scanning, or the NIPCOW disc system confocal microscope. It consists of a spinning disc with multiple small holes, which is inserted between the light source and our sample. The holes allow for a point-like source illumination onto the sample, similar to that of the laser scanning microscope. However, unlike the laser scanning microscope, the NIPCOW system uses a CCD camera as a detection device instead of the photomultiplier tube. The detecting pinhole in this system too serves to remove any background or out of focus light. The point-like light source in this case can also be interchanged between laser and visible light. However, laser is still most commonly used for getting better intensity. Now we will study the pros and cons of different confocal microscopes. As seen on here, there are a lot of advantages of using laser scanning, disc scanning, and multiphoton confocal microscopes. The laser scanning microscope gives excellent image quality, are reliable, easy to maintain, have high readout speed, and have versatile functionality in the sense that it contains 6 visible laser channels, 1 UV laser channel, and 2 infrared laser channels, and thus we can detect up to 8 channels simultaneously. The multiphoton microscope has low toxicity because it only focuses the lasers onto a single point, unlike the laser scanning microscope, which illuminates the entire length of the sample. It also allows for less photobleaching and is an ideal candidate for using living cell imaging. This scanning microscope, despite having similar functionality to a laser scanning microscope, has a high scanning speed. The substitution of the laser to visible light, as mentioned before, can be used to reduce phototoxicity. Confocal microscopes also have some obvious flaws. The laser scanning microscope has a slow scan speed and has higher phototoxicity and higher photobleaching of the sample because it illuminates the entire length of the sample, and therefore it cannot be used to visualize living cells. Multiphoton microscopes are expensive and require extensive maintenance. The lack of a pinhole causes image deterioration. This scanning microscope has a low readout speed because of the CCD camera. We are also limited on the thickness of the sample that we can observe via the NIPCAP system. It gives poor image quality, and despite being multi-channel, we can only use one detecting channel at a time.
Cool. What are some advantages that you found in using confocal over a wide field microscope?
Confocal microscopy uses point-by-point basis,
Mm-hmm.
which allows for a lot less interference from other sources of light emission. So a wide field is going to give you a really blurry, bright image, whereas a confocal will give you a lot of small, really nice resolution points.
Considering the time duration that has passed between Marvin Minsky's original 1955 confocal microscope and today, there have been multiple advancements in confocal microscopy since then. Light sources have been replaced from visible light to lasers. The reflecting mirrors and filters inside the microscopes have become more precise. The scanning and imaging methods have been improved. Background signal removal has become more precise because, as I mentioned before in this video, contaminants can also take up fluorophores and would interfere with our study of the specimen in question. And that leads us to sample preparation methods, which have also been improved and are not only more precise, but more sterile too. The latest development known as of yet is that in the 2004 model, the lasers in confocal microscopes are now being controlled by acousto-optical tunable filters for fast, real-time change of laser line and intensity. And these are some of the variations of confocal microscopes.